again, is relatively short. We'll get started on it tonight, have some lab time, and then finish it up tomorrow night and get 9 done. 9's not very long either, and have lab time tomorrow night too. But we're going to talk about authentication factors and principles, and then authentication systems. Factors, one of those things that was part of networking that we talked about. It gets talked about in a lot of classes because it's something that, kind of a big deal is the authentication. Can somebody get onto your system? So we're going to talk about the AAA process, authentication factors, credentials, and then single sign-on. The different ways to get access to the resources. Again, authentication is when we prove who we are. The AAA process, authentication, authorization, and accounting. The security principles are the users. Authentication, we prove who we are. Could be with a username and password, could be with a smart card, could be with a key fob, could be with a lot of different resources. Could be with the questions that we answer. Not necessarily a good thing if you think about that, because a lot of the questions that they ask are things that people might be able to find on the internet from social media or from other information that's drifting around available to others. And there's nothing says that you actually have to answer those questions truthfully either. You just have to know what the answers are. Authorization, specifying accessible resources, what you can use once you get authenticated. Authorization, can I use a printer? Can I open a file? Can I change a file? Can I use a particular resource? Can I even get on the internet? I mean, I might have some authorizations for there also. Can I run a particular, probably not get on the internet, but can I run a particular program? There may be certain ones that you're authorized to use and certain ones you're not authorized to use. And then accounting tracks the user actions. Accounting keeps track of what we did while we were authenticated, while we were on the network. So prove who we are, what we can do, and then the accounting is what we did while we were there. The authentication factors, and generally we talk about something you know, something you are, something you have. And then we have added, and these are fairly recent, behavior and location. Knowledge, something you know, username, password, PIN number. Possession, something you have. Could be a key fob. And I guess that we could extrapolate, could be a telephone where we get the PIN and then we put in the PIN for the, they don't really call it two-factor, they call it two-step authentication for these things. Inherent, something you are. An iris scan, fingerprint, some of those things. Behavior is something you do. This could be something like your signature, and everybody signs a little differently. The speed, the pressures, as well as the shape of the characters. Maybe typing, could be a keyboard action, but behavior is something you do, and then location is somewhere you are. Geofencing, that we have to be in a certain location in order to access things. And you have some of these places, you're trying to watch TV, that something that you can't get, and you say, oh, it's available in Europe, but you can't get it in the U.S. because they know that it's a U.S. IP set. Geolocators, geolocation of the devices. You may have to be in a certain location in order to access some resources. So location, somewhere you are. So the real authentication factors, something you know, something you have, something you are, something you do, or some place that you are when we do those things. Multi-factor requires two of the factors, not two things, not a username, password, and a PIN, but a username, password, and a fingerprint scan, something you know and something you are. Use a fingerprint scan and a smart card, something that you are and something you have. So the ATM card and a PIN. would be two-factor, something that we have and something we know. Physical token and a password. Physical token is a device that generates usually a string of characters, a string of numbers that you can use that is synchronized with the authentication server. And the one-time passwords, they call them, they're used one time, and normally they have to be used within a minute of the time that they're generated. So they're going to be relatively quick. The password and the fingerprint, the physical key, and an alarm getting into your house, where you open the door with the physical key and then you punch in the alarm code, the passcode, to turn the alarm off. So multi-factor has to have, or two-factor has to have elements from each of these authentication factors. Multi-factor, we could require more, but generally two is sufficient when we do those things. In the digital credentials, everything is digitized, and the biometrics, the fingerprints and the eye scans and the facial recognition, all of that is digitized. It's not exact, it's not precise. These things can be fooled. There is no guarantee that they're going to be absolutely accurate. And inside the system, all factors are data, and data can be stolen. So all of this can be stolen, and it really becomes, in a digital map for the biometrics, an approximation, a really good approximation, but an approximation of what it is. So all of this data needs to be secured when it's going to be stored on these things. The digital credentials and some pictures of some of the things that you may have used, may have seen, may have. The digital credential is verifiable cryptographic signature. A one-time password generated by a pseudo algorithm. The key fob is on the upper there. The credit card with the obviously the near field communication, maybe not, but it looks like they're trying to wave it on those things when we do that. The hardware token stores the one-time password generator or a certificate, and that's what the one-time password would look like. It's synchronized with the server so that obviously it's going to work. We might have a username and password, something we know, and then this thing, something we have that we use it. The magnetic strip card we have, they're considered not secure, so we put the chips, the smart card on them contains a cryptographic chip, contact or contactless. The CAC cards, SIM, different types of cards that are used with these things. And what we see the cards on, the smart cards going to be used for authentication. We see these chips on our credit cards because they're going to hopefully better authenticate what's going on. But, you know, that's only significant if you're physically there, and we have the key code on the back or the number on the back, the security code on the back of them. So all sorts of things they've tried. But you order something online or by phone, they ask you for the credit card number and the expiration date, and maybe the security code. They're starting to do that now, but now the chip cards, when we do things remotely, aren't really helping us a lot. So what kind of payment card security are we going to have with these things? One-time password generation uses a shared secret and a moving factor. Moving factor could be a time of day, could be any number of things, random numbers generated, whatever we're going to do. The HMAC, the hashed system, is based on a one-time password. Hash, HOTP, hash based on one-time password. Uses a hash-based message authentication code plus a counter on these things. The counters that generate the hash so that we don't reuse the hash. And then time-based one-time passwords can be part of the moving factor, that they use a time component as part of the generation of the one-time password when we do those things. Biometrics, you know, you've been there, done that, probably have used those: fingerprint scanner, retinal scanner, iris scanner, facial recognition, voice recognition, all of the different things that might be available for the biometrics, the who we are part of the authentication that we would use. In the biometrics, again, they're not foolproof. We have, like everything else, we need to kind of come to a consensus of what's acceptable. And here the CER is the crossover error rate. That's where we have the error rate and accuracy we have here. The user-friendly, the error rate is high if we have kind of user-friendly security, which may not necessarily be secure security. And then on the right, the security, the high security, where the two cross over, where false rates meet is the crossover rate. The false rates for each of these that we have, the system's been fooled. What this is showing is that the biometrics are not absolutely precise. They're not foolproof. They can be full because the digitization is going to be imprecise. If the tolerance is too tight over here, the high security, false rejection rate, and over on the left, if it's too loose, we have a false acceptance rate. And where the two rates, the false acceptance rate and the false rejection rate cross, is called the crossover error rate. And that's kind of where we are aiming to have the security. If you make it too hard, it's just like you make software or passwords too hard, users are going to not be able to use it. Single sign-on, nothing magic here. It's something that a lot of people have been trying to do over a lot of years. Microsoft tried it with their Live, I guess, to do those. Google's trying it. There are a lot of places that you can sign in with the Confederation. You can sign in with your Facebook, sign in with your Gmail, different things to do that. But single sign-on is where we can access more than one set of resources by using a single username and password. It's very convenient. The issue to me is that if you do that, you get that one password compromised and use single sign-on, a lot of resources are compromised. This is typically something that's used in an environment, a Windows environment. Single sign-on, you sign on to the network and you can get your email. You can get your access to the applications that you can use. You can get your home directory, those sorts of things. But yeah, single sign-on. An example we used to have when I first became the network administrator, we had a Windows log on where you log on to the network, and we were running a Linux email server. With the tech students, not a big deal. They understood that if you're doing Windows stuff, you logged on with your Windows username and password, and if you're doing email, you log on with your email username and password. The usernames could actually be the same, and you obviously could use the same password of two different systems. But the untext, the non-technical users were really a problem because they just couldn't get it, that they had two different places that they had to log on to two different things. We finally put in the Exchange server single sign-on in order to access the Active Directory resources and the email, and then things got a lot better. Not nearly as much confusion with usernames and passwords for those things. And Quanterius, yeah, I think it's risky, but people are doing the confederation of those things. But the single sign-on in its sense is more on our own network and not necessarily on the internet network. Windows is kind of doing, actually Windows is trying to do away with passwords altogether, where the passwords don't really show. You can configure your Windows 10 machine to use a PIN. If you have multiples, you have to have a different PIN on each machine. So the PIN is only locally configured. So instead of using the username and password for a login, you can use the PIN number to log into the system. In that way, the password is never really exposed to those things. Or you can use, you can log into your system with your Outlook account. That's the one that they kind of want you to use, and there are, I guess, other places that you can use those for. But I see those, log in with the username and password, log in with your email, log in with the Google account, log in with your Facebook account, all those different things that can do that. And the trust, what allows that? A federated identity, multiple networks sharing authentication standards. Makes single sign-on easier. We could do that, and down here at the bottom, log in with Twitter, log in with Facebook, log in with LinkedIn, and then log in with email. The email would be your username and then the password that would go there. So some sites, some resources are protected by these federated type of logins to do those. Makes single sign-on easier, obviously. But back to the comment, is it risky? Yeah, to some degree it is. If your passwords, and hopefully if your password gets compromised, you're going to know about it fairly quickly. You can change it, and then the Federation is going to use those passwords on and on. Is it risky? That's kind of a decision that everybody's got to make on their own, is how risky do they think these things are.